Hello everyone. Today we are going to explore an absolutely fascinating possibility that has the scientific community buzzing with excitement. We are approaching a crucial moment in the saga of Comet 13P Atlas, and an exciting question arises. Could one of our space probes manage to intercept and study this interstellar visitor up close? It's October 28th, 2025, and tomorrow, October 29th, followed by October 30th, marks the most anticipated moment in this cosmic story. Comet 13P Atlas will reach its perihelion, the closest point to the Sun in its orbital path. This is an absolutely critical moment that will determine much about the next chapter of its journey. At this very moment, the comet is virtually hidden behind the Sun's disk, invisible to Earth-based observers. The intense solar glare completely overwhelms any attempt at direct observation, but in just a few days, it will emerge on the other side, reappearing in the sky and finally revealing what happened during its close encounter with the Sun and its intense heat. The anticipation is palpable. What will we see when the comet resurfaces? Has it survived the intense solar radiation intact? Will it have developed a spectacular tail? Has its structure remained cohesive or fragmented under thermal stress? All these questions will be answered in the coming days, as humanity watches with great anticipation. ChatGPT DC, a remarkable achievement of modern space exploration, is that humanity is no longer limited to observing the cosmos from the surface of our own planet. Over the past decades, we have launched dozens of space probes that are now scattered across the solar system, acting as our eyes and ears in distant locations. We have probes orbiting Mars. We've already seen spectacular images of 13P Atlas captured by these Martian observers. We have missions en route to Jupiter, including NASA's magnificent Europa Clipper, designed to study the icy moon Europa and its subsurface ocean. There's also the JUICE mission from the European Space Agency, also heading toward the Jovian system. And we have Juno, which has been orbiting Jupiter for years, uncovering the secrets of the solar system's largest planet. Beyond these, there's the Hera mission, also from the European Space Agency, currently en route to the asteroid belt with a fascinating objective: to study the results of NASA S-DART probe impact on the asteroid Dimorphos. This was humanity's first planetary defense test, and Hera will examine in detail the crater left by the impact and how the asteroid S structure was affected. With all these probes scattered across the solar system, an intriguing question naturally arises. Is any of them positioned to intercept 13P Atlas? More specifically, could any pass through the comet's tail? Here, it's important to make a distinction. When we talk about touching the comet, we're not necessarily referring to a direct collision with the solid nucleus. That would be extremely difficult to plan and execute with probes currently in transit, as they were not designed for such a mission. What we're really discussing is the possibility of a probe passing through the comet S-tail. A comet's tail is a fascinating structure. It's not a solid object, but rather a mist of gas and dust ejected from the nucleus as solar heat sublimates its ices. The tail can stretch for millions of kilometers, always pointing away from the Sun due to solar radiation pressure and the solar wind pushing the material outward. Passing through this tail would provide extraordinary scientific opportunities. Instruments on board the probe could directly analyze the cometary material's chemical composition, measure particle density, study plasma properties in the tail, and collect data impossible to obtain from distant telescopic observations. A dedicated team of researchers conducted a detailed analysis using sophisticated orbital mechanics software to determine whether any of our space probes might be in the right place at the right time. The results are extremely promising. Two missions in particular stand out as prime candidates: Hera and Europa Clipper. Let's examine their orbital positions and why they have this unique opportunity. 13P Atlas is currently passing through the space between the orbits of Mars and Earth. This is a region of the inner solar system where, fortunately, we have active spacecraft traffic. Simulations show that both Hera and Europa Clipper could have their trajectories intersect with the comet S-tail. Visualize the geometry. The Sun is in a certain direction. The comet passes close by. And solar radiation pressure pushes material away from the comet, to form a tail extending opposite the Sun. The orbits of Hera and Europa Clipper potentially place them within this zone where the tail will extend. If 13P Atlas develops a substantial tail, and all indications suggest it will, given its increased activity near the Sun, there is a very real chance that these probes could pass through it. This would be a historic event, the first time a human-made spacecraft traverses the tail of an interstellar object. Timing is crucial. The window of opportunity is relatively narrow, opening between October 30th and November 6, 2025. During this one-week period, the relative positions of the comet, the spacecraft, and the Sun align favorably. On October 30th, just after perihelion, the comet will begin to develop its tail most prominently. As it moves away from the Sun over the following days, the tail is expected to continue extending, potentially reaching tens of millions of kilometers in length. It is during this period that the Hera and Europa Clipper probes will pass through the region where the tail may be present. Simulations show that given the orbital positions of the probes and the expected direction of the comet's tail, there is a significant spatial overlap. In simple terms, the probes will be in the right place. The question now becomes, are we ready to take full advantage of this opportunity? Although the orbital opportunity exists, there are significant practical and bureaucratic challenges that must be overcome to turn this possibility into reality. First, there is the issue of mission programming. Both Hera and Europa Clipper are currently in cruise mode, an operational phase where many non-essential systems are turned off or in power-saving mode. Their main cameras may not be active, and many scientific instruments are in hibernation, conserving energy and resources until the probes reach their primary destinations. Activating these systems, reprogramming command sequences, and reorienting the spacecraft to point instruments in the correct direction requires careful planning, extensive testing, and approval from multiple teams. Space agencies are necessarily cautious, as any misplanned command could jeopardize missions that cost billions of dollars and represent years of work. There are also considerations regarding instrument capabilities. The cameras on board these probes were not specifically designed for comet observations. Europa Clipper is optimized for imaging icy surfaces under specific lighting conditions around Jupiter, while Hera was designed to study rocky asteroids at close distances. Adapting these instruments to observe a fast-moving, dynamic comet presents significant technical challenges. It's worth noting that humanity already has experience with spacecraft encountering comets, though never before with an interstellar object. The European Space Agency's Rosetta mission is the most spectacular example. It not only traversed the tail of a comet, but also orbited Comet 67P Churyumov-Gerasimenko for years, studying it in unprecedented detail and even landing a module on its surface. Other missions have also had cometary encounters. NASA's Stardust probe passed through the coma of Comet Wild 2, collecting dust samples that were later returned to Earth. Deep Impact deliberately launched a projectile into Comet Tempel 1 to study its interior. The European mission Giotto approached Halley's Comet in 1986, flying at dangerously close distances. These precedents demonstrate the immense scientific value of in-situ comet studies. Each mission revealed unexpected details about the nature of these primitive objects. An encounter with 13P Atlas, even if brief, could provide unique data on the composition of an object formed outside our solar system. This situation with 13P Atlas highlights a need the scientific community has long recognized. We require rapid response capabilities to study unexpected transient objects. The European Space Agency, ESA, is actively developing a concept to address exactly this need. The proposed mission is called Comet Interceptor, and it represents a revolutionary approach to space exploration. Instead of being launched directly to a specific target, the Comet Interceptor would be positioned in a parking orbit at the Earth-Sun L2 Lagrange point, a region of space where gravitational forces balance in such a way that stable positioning requires minimal fuel. There, the spacecraft would wait in readiness. Ground-based telescopes constantly scan the sky, discovering new comets and asteroids. When a particularly interesting object is identified, perhaps another interstellar visitor, or a long-period comet making its first passage through the inner solar system, the comet interceptor could be rapidly redirected to intercept it. This flexibility would be transformative. Currently, it takes years to plan, build, and launch a mission to a specific target. With a mission on standby, we could respond in weeks or months, enabling the study of objects that would otherwise be impossible to reach. The Comet Interceptor would be equipped with instruments specifically designed for comet studies, spectrometers to analyze composition, cameras optimized to capture faint structures, dust detectors to measure the particle environment, and magnetometers to study interactions with the solar wind. It would be the perfect tool to seize opportunities like the one that 13P Atlas currently presents. We are literally days away from answers. When 13P Atlas emerges from behind the Sun in early November, we will quickly know whether the Hera and Europa Clipper spacecraft were activated to attempt observations. Space agencies will have made their decisions, weighing the risks against the potential scientific rewards. If the observations take place, we will be witnessing history in the making. Direct data from an interstellar object collected by human-made instruments in deep space, revealing secrets about the formation of planetary systems beyond our own. Every measurement, every image, every spectrum would be a scientific treasure. Even if operational limitations prevent a direct encounter this time, the opportunity has served a valuable purpose, highlighting the need for rapid response capabilities and generating public excitement for space exploration. It will also inform the planning of future missions like the Comet Interceptor. 13P Atlas is performing its cosmic dance through the inner solar system, following the immutable laws of gravity established billions of years ago. Humanity, with our technology and curiosity, is positioned to potentially intercept this celestial dancer, even if only briefly. In the coming days, we will watch closely. We will await the first post-perihelion images of the comet. We will anticipate announcements from space agencies regarding whether observation attempts will be made, and we will continue to learn, marvel, and expand our understanding of the universe we call home. This is the essence of space exploration, seizing unexpected opportunities, overcoming technical challenges, and continually pushing the boundaries of human knowledge. 13P Atlas offers us one of these rare opportunities, and the world waits to see if we can make the most of it.